Okay, can you hear me well? Yeah, good. Right, my name is Saied, and I work for Visma Software International here in Oslo. And I work as a security and machine learning architect. So basically what that means, I try to do a security and machine learning. So I'm going to bore you for 45 minutes talking about machine learning for the purpose of security. Okay, so bear with me, please. Right, the objective of this topic or this presentation is to slightly go through machine learning and how to build machine learning models for your organization, for your project, the ingredients you need, the steps and all that things around it. So lately, artificial intelligence and machine learning becoming very popular among all the organizations, and I would like to sort of go through the empty and good promises that you might get out of models. Then I'll try to cover 2 use cases and a bit of source code and how you can build your own machine learning models for your organization, okay? Before I talk about machine learning, I would like to talk about data, because data is very important in any kind of business. So if you look at the circles around the right-hand side of the screen, you would see different kind of business, from financial to medical, cultural, governmental, mathematical, scientific. All of those businesses that you see, they have something in common, and that is data. So data is the fundamental backbone of any kind of business that we work with. Without data, you can't really make sensible decisions. Without data, you'll be out of job. Right? Without data, you cannot diagnose medical issues. So it is vitally important and is the backbone of everything that we do. But what is data? The simplest definition for data is just information. Okay, information in a form of text, image, videos, numbers, so everything that we experience on a daily basis. That's just data. And that could be structured or unstructured, depends how you put it in your organization. But from the security point of view, data could be private, it could be secret, could be personal or publicly available. So if you have publicly available data, you don't really need to do so much around it. The content of it is there for you to download, to use, to sort of play around with it the way you want, depends on the license, obviously. But when it comes to secret and private data, this is where you guys spend a huge amount around it. We want to protect the integrity and the confidentiality of that data. So, data and security. So all of those things that we've been talking about for the last couple of hours, and all of those things that you guys do on a daily basis, hopefully, from authentication to authorization to factor authentications, firewall, password, session security, pen testing, secure coding, all the way down to security awareness. We do all of those things essentially just to protect data, right? We want to protect a service or something that contains that data which is very dear to your organization, to you, or to someone. Unless or otherwise we have publicly available data, which we don't really care that much because everything's public. Otherwise, when it comes to secret, personal, private data, we do all of these around it to protect it. Now that's great, this is what we do. But what if we use data itself to protect data? What if we mathematically understand the available data and learn its characteristic features and its behaviors? And using this learning process to predict attacks to your service. In another word, if I have a huge amount of data and I can use that data somehow, convert that data into some mathematical representation, and use that to create a model to predict some cyber attacks and authorize access to your servers. This mechanism is really known as machine learning, which is a branch of artificial intelligence. Basically, machine learning has been around for a very long time. It's been used for many things, and it can be used for security purpose as well. So, machine learning, in short, you actually do three things. You have a huge amount of data, where you try to understand its characteristic features, the behaviors, the examples, the scenarios towards your service. If you take, for example, Scott's data set that he has, there are a lot of characteristic features that describe a set of scenarios towards specific services. So that's fantastic. You can use that. And if we somehow convert all of those characteristic features, those examples, into some numerical representations and feed that into a learning algorithm, and tell the algorithm, please, if you come across, hypothetically speaking, if you come across these kind of scenarios or situations, take these kind of actions. Or you could just say, can you make sense out of this data for me? I'm speaking hypothetically. Obviously, you need to go through a series of steps. And throughout that, you get some prediction, some classification. You identify some abnormalities towards your service. So, machine learning can, and it has been proven, that can identify different types of attacks towards your service. That could be user behavior, unauthorized access, DDoS attacks, can do facial recognitions. We see it on different airports nowadays. Spam detections. You can do anything really with it as long as you have the right and applicable data for your problem. And that is the key. That's the most important thing. So again, we're using data and the content of that data to protect ourselves, or to protect that data itself, somehow. Right. So how are we going to do this? You, as an organization, you have a project, you want to start, you have a huge amount of data, and you want to make sense of it. You want to see, how am I going to use that data for a security purpose? From my experience, one of the most important things that you need to do, and you have to ask yourself, what is it that you want to protect? Is it a service? Is it a network? Is it an application? And I'll tell you why this is important all the way down towards the end. And the second most important thing, who should be the applicable people for this process? It's vitally important that those who are a part of this process need to have the domain expertise in this. You need to have a proper security guy, someone with a machine learning background, and I'll tell you why. Those individuals will actually decide the characteristic features that need to be selected out of that data. So let's assume you have a 30 gigabyte of data and you want to do something out of it. It's really silly to use the entire 30 gigabyte of data. What you need is to select the most applicable attributes of that data to use it for your problem. Because you want to, protect something. And that will lead to selecting the right data for your problem. And here we go, you have your data ready. If, for the sake of the argument, the security guy and the machine learning individual in this box weren't really the domain expertise, they might select wrong characteristic features for that problem. And what do you mean by characteristic features? Characteristic features are some behavior towards your network. So it will describe some examples, some scenarios, like those, I think Chris showed quite a lot of things that you have to do in order to get access. Those kind of behavior, those kind of patterns and attributes are the characteristic feature for that particular attack. So that is what you need. Okay, I'm going to use those information, and I'm going to prepare that information and feed it to a learning algorithm in order to make sense of it. And that's done mathematically at the background. So that was the preparation for the data. Then you start with the implementation. Within the implementation, you go through three important phases. And the first one is the pre-process the data. So that data, if you remember, we said it could be voice, it could be image, it could be videos, it could be anything. You need to convert those data into numerical representations so that the machine learning model can actually understand it. And this is where you spend a huge amount of time. You combine statistics and some other approaches to do this conversion. And you prepare that and you feed it into a learning algorithm. And that is second phase, the training process. And hypothetically speaking, what we are saying here, please machine learning model, I have these kind of examples. If you come across these situations, take these actions. And I'll further explain that as we take each of them individually. Towards the end, you have a model. And that model is supposed to be an artificial intelligence model. It has to do something important for you. It has to replace. You have a driverless car. You know, we have a model that replaces the driver. So the accuracy of that model is vitally important towards the end. You do want to identify the relevant attack, reduce the false positive as much as possible. And that's very important. So you, again, towards the end, apply some statistics there. And then use that to verify the ending of your model. Right. So let's take each of them separately. There are a lot of things you need to do when it comes to data pre-processing. And these are some of them. You might do them when you start or during the whole process. And I'll explain that as we go. And this will be really easier as we go along, hopefully. So, as I said, you have data, you need to convert these data. So one of the things that you do, you need to convert categorical, image, ordinal, text into numerical representations. You focus on missing data. You know, you want to do whether you either replace them or you delete them. You identify corrupted data, noisy data, and remove it completely from your data itself or from this process. Maybe you imply dimensionality reduction, normalization. All of these are, some of them or all of them, are statistical approaches. Now, once you have done, and you might ask who's going to do this, this is a job for the machine learning guy or someone with a machine learning background. Okay? Now, and then once the data is ready, is prepared, you feed it into a learning algorithm. So, and this is really important because you have three to four different approaches when it comes to learning algorithms. You have supervised learning, you have semi-supervised, you have unsupervised, and you have reinforcement learning, which I don't have it there. Now, when it comes to supervised learning, you label your data in a sense, well, hypothetically again, you tell the learning algorithm, if you come across these examples, these scenarios, these situations, please take these kind of actions. And the most important thing from the learning perspective, the model actually has to understand those possibilities rather than memorize them. So we are not doing pattern-to-pattern match. We're actually teaching, hypothetically speaking, we're teaching the model to understand various situations and act based on these examples. So that's one way of doing it. And that's called supervised learning. So we teach the model. Supervisively, we teach the model. The other approach is unsupervised learning. We don't have really labels there. What we are saying, okay, I have a huge amount of data. Can you make sense of it for me, please, hypothetically speaking? And then the learning algorithm or the model will try to figure out, it will cluster them. It might find associations between those attributes, or it can sort of, identify abnormalities or anomalies among them. So that's one other approach. Or you can combine sort of half-labeled, half-unlabeled approach, and that is semi-supervised learning. There is another approach, it's called the reinforcement learning. And this is, to easily describe this is like having a dog. For everything that the dog does, you reward it. So you go from A to B, here you go. You get something from B to C, here you go. And the dog will learn based on these experiences. But I haven't covered this in this presentation, though. So once the data all the possibilities I've learned, or all the classifications have been done, or clusters been made, then what you need is to verify this. You want to make sure that this model is actually working in production environment, that doesn't bluff, basically. In here, you combine statistics with approaches. So you do things like accuracy, R2, mean square. These are all statistical approaches, where you combine it with some approaches such as data splitting, cross-validation, and all that kind of stuff. So why you do this? You want your model to actually predict the right thing, And as we go along, as we talk about the examples, you understand what I mean by this. So accuracy is the most important thing. And we want a model to learn all the possibilities that we have introduced to. We don't want a model to memorize all of these possibilities. It's like having a student. Think about it like this. You have a student that memorizes an entire textbook. It does really well in the text exam, but when you put it in real life, really bad, because that student didn't really learn the materials. And this is what we're trying to do here when it comes to modeling artificial intelligence. Right. And that will lead me to something very important here, which every time when you create models, an artificial intelligence model or a machine learning model, you come across this problem all the time. And you might experience it on daily. If you've done machine learning before, you know this is very possible. I call this empty promises versus good promises. So what I mean by this, from the security point of view, the model has a high accuracy when you test it in a test environment. But when you put it in production, it's really shit, in a sense that it produces wrong prediction, it confuses good requests with bad requests, and all that kind of crazy things. Why? Because the model memorized all the possibilities as opposed to learn all the patterns. What we want to do when it comes to this is, as part of this process, to get close as much as possible towards good promises, in a sense that the model correctly identify, for the sake of the argument, genuine and bad traffics correctly, both in test and production environment. And how are we going to do this? Right. Every time when I face this problem, I go back to square one. I ask myself, am I doing the right thing? Am I protecting the right service? Am I selecting the right characteristic features for this problem? Because selecting the wrong characteristic features will lead to wrong data sets, and hence you're doing something really irrelevant to that problem. Am I doing the right data processing? The statistics that I'm using there are correct or not? What kind of model I have used? Have I used supervised learning, unsupervised learning? So you keep going, and you're looping around as many as 100 times until you get to the right answer. Until you're fully convinced that whatever you get in terms of 80% accuracy in test environment and production are the right and qualified figure. And then you're good to go, but you're not really good to go, and I'll tell you why. So to further explain all of these, I'm going to talk about two use cases that I've personally involved with. One of the things that we wanted to do at Visma, we try quite a lot combining security and machine learning and artificial intelligence together in various parts of the company. And one of the cases I was personally involved with was this one, is to design and implement an effective lightweight agent that detects and classifies abnormal behavior towards a service. So this is very interesting in terms of abnormal behavior. What do we mean by abnormal behavior? Okay. So we sat down and we sort of tried to understand what abnormal behavior, and in the context of that project, abnormal behavior could be a bad intention. Someone who's trying to hack or attack your website with different approaches and mechanisms, okay? or someone with no intention, because your system is crap, basically, the way it was designed, people know how to use it. As a result of that, the model shouts out, hey, someone's trying to do something, but in fact, it's not the model, and it's not the individual. It's actually the way the UX design of your system. So through this process, we didn't even identify whether we found anomalies or anything like that. We identified how the UX around certain services were built. Right. So what we did, we got a huge amount of data containing genuine activities. So first of all, we had to identify all of those genuine activities towards that service, and genuine activities that someone was genuinely trying to use the service. And then we got another data set which contained malicious activities towards those services. We know these are malicious activities. And then we combine them together. So we label them. We have a data set saying, if you come across these kind of genuine activity, please flag 0 when you experience them. But if you come across malicious activities like this, flag 1. Right, so how did we do this? We had the data, we pre-processed the data, and again, we fed these information to the training model. We tried different possibilities, different models at the same time. And towards the end, we evaluated it. Obviously, we had to go back. But what was really, really important for this process is to have a model that understands all of those possibilities that we use for the training purpose. And that was the essential part. But during that process, we had to add new data into it as part of the process. And as we go along, I explained why we needed to do that. But at some point, we were ready. We had an API, so every time when there was suspicious activity towards that particular service, we send those patterns into the model, and the model was responded, okay, this activity looks suspicious, so that's 1. Or this is not, that's 0. So it's a binary classification within this context. When we started, we had 72% accuracy. And then we moved all the way to 85% accuracy, and then towards 92% accuracy. So before I go ahead, let me explain what I mean by accuracy here. 92% accuracy means the model is successfully and correctly identified all of those behaviors towards the service, towards the endpoint, whether it was bad behavior or whether it was good behavior. Because what we're trying to do, essentially, we try to identify behaviors, how people, services, certain things are trying to use this service. And out of these behaviors, we want to know whether this is an intention behind it or not. Okay? And that went up to 92%. And we thought at the time that is really good, because 92 out of 100, this is good stuff. So to get into that stage, we did a lot of things, a lot of statistics, a lot of methodologies, like we had to tune the algorithm, we identified overfitting, we did normalization, we tried different tokenization and stuff, cross-value, name it. And then we also applied different statistical scoring in there. But then that was one of the cases, and it went really well. Then we started with another case, which instead of having one endpoint, we had multiple endpoints. So the problem was it was a bit more complex than we thought. So one of the challenges that we had, the number of calls or the number of transactions toward those services are way above 6 million plus. So the volume of traffic towards those endpoints are really big. Initially, so yeah, we wanted to, again, the requirements was to identify behavior, again, towards those services. We want to know that Scott is trying to do something, or whether someone is trying to, what kind of suspicious activities do you have towards the service? So one of the other requirements, we didn't want to change too much infrastructure or have a complex solution in place. So when we analyzed the problem, we thought, okay, we know the endpoints, we know all the genuine characteristics towards those endpoints, and we thought, okay, we're going to formulate some patterns, and we create some rule-based, the classic rule-based. If you come across this, is this, then yes, off you go. But then we straight away experience these problems. The number of clients, the number of users, and the number of installations towards those endpoints were increasing very rapidly. And that means every time when we have new customers or new installations, behaviors towards those endpoints are increasing rapidly. Because each user, the way they use a service is different from another user. So if we want to use rule-based, that wasn't really a solution. So instead, and apart from that, the number of endpoints were increasing at the same time. So what we did, again, we used machine learning. We identify all the characteristic features, pre-process it, and in this case, we use unsupervised learning, where we actually have identified some anomalies there. Now, what was really interesting here, when you in this kind of world of artificial intelligence / security, when you find anomalies or someone who's trying to do something, you always ask yourself, is this a false positive? Is this a real guy or not? Because you're predicting, you're predicting something. And usually, in this kind of business, you don't straight away go for the individual and say, okay, what are you doing there? Because you get the intel and you compare it with some other intels, then you make your decision. So we found some anomalies across those traffics, but some of them, they were genuine people, but they didn't know how to use the service properly. And there were a couple false positives and one or two, bad boys. Right. So one of the most important things, again, when it comes to machine learning and artificial intelligence and all the things around, this kind of domain, is the life cycle or the process of it. So you start with data. Remember, we said data is the backbone of this business. Without data, you can't really get anything out of it. We try to use data to protect the data itself. We pre-process it, we train it, we evaluate it. Then you deploy it to production. And it's not that once you're in production, you leave everything and life is good. No, you have to analyze the output of that. And you keep going back again and again and again. Why is that? Because, again, we're dealing with behavior. You might get new behavior that overrides the existing behaviors that you used to train the model. So you need to be aware of, okay, some other services might be a part of this. So it might change the vector or the direction of your model to somewhere else. So you need to follow up with that. So behavior is extremely important in this business. So you always have to monitor that and analyze it. Okay, so I would like to also give credit to these guys, including myself, for working on this at Visma. I just wanted to mention their names. But let's go ahead with a show and tell. I'll show you some codes. Okay, so before I explain the source code, in this model, what we're trying to do really, we're trying to get the URL that people type in, and we try to get that and feed it into a model to see whether there is any bad intention behind that or not. So all of these things that Chris was talking about typing in, and I think Ellen was talking about doing all. So when these things go somewhere, we capture them and we try to feed it into a model and see whether this guy is trying to do something good or bad. So that was the object. This is the objective of this model. So it's really simple, really, not that difficult. So in here, we talk about pre-processing the data. So we completely pre-process the data. We use tokenization, and we normalize it. And we use different learning algorithm. And here we use artificial neural network, linear discrimination analysis, logistic regression, all the way down to SVM. Sorry. And then we use cross-validation, like k-fold, to verify whether this model is really good enough for our purpose or not. In here, we got some output saying that if you use artificial neural network, you get 92% accuracy. If you use logistic regression, 92%. If you use k-neighbors classifier, it's 89, and different values. Now, we chose logistic regression, and I don't know why I chose that. I just felt, choosing that. And then in here, we have saved the model. So let's have a look at the model. So how the model look like? This is a model that we have created. The aim of this model is when you have this URL, you feed it into it, and the model will try to understand whether you have any bad activities towards your network or not. And when you look at it, it's just gibberish, really. It doesn't make any sense, which it should. Because what we are having here is not a classic rule base. It's not that we are capturing a pattern and we compare it with something in a database. No. We are hoping for this model to understand how these things are and predict out of it. Now, before I test it, so let's test it here. In Visma, we have this program, I think it's a bug bounty program or something, that we invite security researchers to identify vulnerabilities in our solution. And nearly 2 months ago, there was this guy who identified this content management problem in one of the Citrix services that we had, and he managed to get in and do some nasty stuff, and he got paid for it, obviously. And so afterwards, what we did, we tried to see whether we can, the things that he did in terms of the URL, we feed it to this model to see whether it can actually predict this to be malicious activity or not. So when we tested it, we'll run it here. Yeah, so the response was positive, saying, okay, whoever had tried this URL has a bad intention. So if you look at the URL, it says citrix.visma.com, followed by blah, 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 themes, blah, 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 uploadify.php. Now, what was really interesting about this, we have never trained the model with this possibility. And yet the model identified this to be a malicious activity towards your service. And the model never cared about the content of uploadify.php or that kind of stuff. From the model's point of view, that doesn't really matter. We trained the model using different type of data. We have told the model, if you come across these kind of observations, take this kind of action. And the model used that understanding to identify this URL to be malicious towards your service. And I was so fucking happy about that. I actually emailed everyone in the organization, to tell you the truth. Right, let's go back here. Yeah, so what you need to understand, when it comes to machine learning, what we are trying to do is to provide intel. One of the most important things, again, you should not replace all the existing services, like security services that you have with a machine learning model. No, this has to complement the services that you have, the security services you have. So we don't, at least in our project, we didn't care about the defense mechanism because that is very costly. We leave that to someone else to deal with. In a big organization, you rely on different type of agents to provide you with information. And towards the end, you have a decision maker. So you have a couple of machine learning models to provide you intels. You have a rule base that will provide you further intel, maybe a third-party supplier to provide you much more further information. And towards the end, yeah, you have either a process to start with a defense, or I'm in favor of activating a honeypot to learn more about the attackers. Just let them what they want to do. Just learn about their behavior and use those behavior as a data and enrich your model with that. That would be a neat approach. Right, all in all, that's my, do I have time? Yeah. All in all, when it comes to machine learning, first of all, as I said, you have to have a clear understanding of what you want to do. Those individuals are involved with your problem. Try, they need to know what they're talking about, because if they are noise, as I call them, they will select wrong characteristic features for your data. Spend time learning about your data. Don't rush straight away to create models. Understand all the scenarios. At the same time, try to evaluate your model based on unseen data. Create pipelines. And thankfully, nowadays, these things are actually available in cloud solutions, so you can use them. But be careful with what you get. When you put it in production, try to analyze the output as much as possible and use that to retrain the model. And that's me, machine learning and security. Any questions? Okay, yes? No, you. I'm joking. Yeah, you.
You mentioned that you have multiple approaches in terms of the machine learning algorithm. Have you tried, and what were the results, to combine the same data input but on multiple machine learning algorithms, and then using the composite of the outputs to determine where it's...
Oh, you mean using multiple algorithms for the same purpose?
For the same purpose and the same data?
Yes. In one of the cases, yes, we have. And we have learned that deep learning provides an excellent result. Yes. And that is one of the things that you actually have to do. Is a good approach. Yes. Yes, sir. Yes? Yeah.
So, about this accuracy, because you... Okay. Hello?
Yeah.
The accuracy. It was a really good talk. Thanks.
Thank you.
But the
We'll
accuracy, because as I understand it, you both machine learn the system itself, how it works, and also the bad behavior. Isn't that
sorry,
true?
say that again.
You both machine learn how the system itself works, because that is difficult to find out. And also the bad behavior, both the good behavior and the bad behavior.
Well,
you have to machine learn what is...
you create a model to understand, let's call it genuine activities towards your service versus malicious activities.
Yeah. So how do you know that you have a correct understanding of your good behavior?
That is a very good question. And I'll refer back to this guy over here. Where are we? Are you ever going to get there? Yeah. So this one, who should be involved in what and what kind of skill sets? And that plays an important role. For example, if you want to protect your service against DDoS attacks, okay, you need to bring someone with that expertise to identify the relevant patterns for that problem, not someone with cross-site scripting for the sake of the argument.
I have a question more.
Yeah, sure.
What security problems do you discover and what do you not discover by machine learning? So what are out of scope of these methods and what are in the scope? Do you cover platform security issues on the client, or is it only network traffic, or is it? Yeah.
We are hoping.
What do you cover and what do you not cover?
At the moment, we are, as I said, one of the models. We want to cover how people use the actual service by itself and learn about the behavior of that. But in the second scenario, we focus on the network. Yes, how services using the network, and this is we found a lot of noise. Yeah. Anyone else? Yes.
Hi there. Thanks for the talk. I was wondering something you said at near the beginning. These are all the things we use to protect our data, and machine learning is not going to replace all of that. It's going to be another part or a layer.
It's a complementary service, yeah.
Yeah. So taking it in that way, how do you feel about the future? You're talking about the security person and the machine learning person working together. How many organizations are going to have that, or is this going to mature to a point where it becomes consolidated as an industry with a few players? No one would make their own SIM solution. Of course, they might implement and further develop an open source SIM solution or buy one. Or IDS and so on. Will it be something like this, or how many organizations do you think will realistically have a machine learning and security team working together?
I would say larger organizations usually go for this. Either they go for third-party solutions. There are a few third-party solutions out there, but they are very expensive. Or you can build your own. So from big organization point of view, yes, they are going for this. I think the problem the future of pen testing, for example, or security somehow at some point in time will shift towards this direction. And the purpose, so to say, for this presentation is to be aware that at some point in time that you would have pen testers that are based on machine learning. There are a couple of projects out there. I encourage you to study them. They have already started to have pen testers based on machine learning. So what in one of the projects, I don't quite remember what was it called, but it uses reinforcement, which means basically when you type all the commands and possibilities towards a service, to attack the service, there's a model of the background, tries to understand you as a pen tester. And then it will try to imitate that behavior, and that become the actual model to launch the attack afterwards.
I think there was the Cyber Grand Challenge, was a CTF event at DEF CON that was fully automated, red versus blue simultaneously. Yeah. So you think that will come eventually, but not
well,
not there
I
yet.
think at some point, at least at Visma, we try to inject this with the blue team. And hopefully in future, we want to do pen testing based on artificial intelligence as well. And that is one of the initiatives that we would like to take.
Cool. Thank you.
Sure. Yes, sir. You. I can hear you. That's all right.
Maybe it'll be one that we have to take offline. So, the question is in context of Report Your Eye that I run. So we see websites blocking these JavaScript URLs, like crazy domain /keylogger.js, whatever. So the thing that I can't kind of understand is, would the model be able to just look at the full URL of the remote script that was blocked and understand based on some kind of pattern that it was expected or not? Or would I have to feed in other data, perhaps like a domain reputation score from an external API, or like...
Along the line, yes, you have to feed more information. As I said, if I go back to this... sorry, just one sec. Yeah, why did I say I'm in favor of having an honeypot? Because I would like to learn more about those behaviors. The more behaviors I know, the easier for me as human to understand and learn about this problem. And what we are trying to get out of this model is to think and behave, hypothetically, like me. Okay? And we're doing that by somehow mathematically convert all of those behaviors into some numerical representations and feed it to the model. So, sometimes, those behaviors will change, and that will change the direction of your model completely to somewhere else. So you need to be a bit careful. It's not just, you leave it there and life is good.
So eventually it would be able to do something like the Russian domain that I showed earlier. I would
Right.
look at that as a person and say, this looks
Suspicious.
And
Yeah,
the model would be able to replicate.
precisely. This is what we
Okay.
experienced with the Citrix Visma thing.
Okay.
Yeah. Yes, sir.
I see. There is. What I'm thinking is about that you will have a very few numbers of positive, I mean, attacks among a huge amount of negatives. How do you filter out all the negatives? Like.
You mean, okay, so
How
what,
do you
what
find
you're
a
saying,
very small, like you have a very low
are you referring
signal?
as false positive or?
No, I'm talking about you have a very
Successful
small
attack.
signal that is the successful attack
Okay.
among another signal that is all the possible legitimate.
Okay, so how you
requests.
separate them?
Yeah.
Okay, this is a part of the data set itself. So you, as I said, you tell the model, if you come across these kind of possibilities, let's assume they are genuine scenarios, you flag it as 0. That means you don't have to worry about them as an intel. But if you come across these possibilities, then flag them as 1, meaning they might be malicious. They might be malicious, okay? So what we are trying to get out of this, we want the model to understand and learn these possibilities, whether they are bad or good. And out of that, we want the model to predict, based on the learning process, how this traffic is. It might be false positive, we don't know. But if you bring someone and look through a set of data, you either right or wrong, based on how much experience you have. And you gain this experience based on how much you know the field. And we're trying to teach the field into the model, hypothetically speaking. Yeah. Thank you. Thank you very much.
So we'll have a short break, but just before leaving for the break, how many people are, by show of hands, how many people are planning to attend?